Hi students, today we will discuss about the drift velocity. So you know, whenever there is a conductor and if we are applying a potential difference across the conductor, then there will be a current flow. So current flow means the charge is flowing. So how the charges are flowing inside the conductor? So that is due to the drifting. Drifting means we have applied an external electric field, so positive charge and negative charge. So the positive terminal of the battery that will attract the electrons, free electrons which are available inside the conductor. Similarly, the negative terminal that will repel the electrons. So this type of movement of the electrons inside the conductor is known as drift. So drift velocity, that means the average velocity with which the electrons are gets drifted from the negative terminal of the battery towards the positive terminal of the battery across a conductor. So we'll go for a derivation. This is a very important derivation and normally it is asked in your CBSE exams. So now see how we'll derive. That is drift velocity. What is that? Drift velocity. So drift velocity, it is denoted by VD. So we'll go for this derivation. So now let us consider a conductor of length L. So if no battery is connected across the conductor, then the free electrons which are available inside the conductor, they will be in the random motion in different directions due to the thermal agitation, right? So this type of motion is random motion of the free electrons, and the average velocity of all the electrons initially when there is no battery is connected, that will be 0. So the average velocity of all the electrons which are available inside the conductor in the absence of any external electric field, that will be 0, right? So here we get one thing, that is your U average initially, that will be equal to 0. That will be equals to 0, right? This concept is clear. Now suppose we are applying the electric field. We are applying the electric field across the terminals of the conductor. Now you see what will happen. Now we can see these electrons which are revolving, that is these electrons which are moving inside the conductor randomly. Now they will be aligned to move in a particular direction. So what is the direction? So if is the potential difference is V, then these electrons, this is negative terminal, this is positive. So free electrons will be moving from negative to positive. So the electrons will be repelled by the negative terminal and it will move towards the positive terminal. So this is the direction of the electron flow. So you know the direction of current. So if we talk about the direction of current, that means this is the conventional current. Conventional current means the direction in which the positive charge is moving. The positive charge is moving. So this is opposite to the direction of electron flow. So the current will flow in this direction. Let this current is I. Let this current is I. So this conductor, already we have assumed that L is the length of the conductor. Then the I is the current. Similarly, when these charges are getting drifted from this to this, suppose they are moving with the average velocity of Vd. So Vd is your drift velocity. Already we have considered, right? So now you see here what will happen actually when the external electric field is applied. When the external electric field is applied, these electrons are drifted from the negative to positive. So suppose we are considering about one electron. So what was its initial velocity? Suppose u1. So we are considering only for one electron. So for the one electron, suppose the initial velocity is e1. This is the initial velocity, right? Similarly, what will be the acceleration when the external electric field is applied? You know, a charged body in an electric field experiences a force. So what is the relationship between force and electric field intensity? That is F is equal to Q into E. Right? Now, this force is applied on a charged body. What is the charged body? This is free electron. So, when the force is applied on the electrons, it will be accelerated. So, if m is the mass of the electron, then this F will be equals to ma, where a is the acceleration with which the electrons are accelerated from negative terminal to positive terminal. So what will be the final velocity when the electron is drifted from this end to this end, covering a distance of L, right? So this is the acceleration A. So equating these two, we'll be getting QE is equal to MA. So the acceleration will be equal to, you know, QE upon M. Here this will be negative. The reason is that the acceleration are getting drifted in opposite to the electric field, that is negative to positive. So in this case you can find the charge on electron is E. So the value of A will be equal to EE upon M. So this is negative sign. Again, you are knowing that E is equal to potential gradient. So the potential difference is V, the length of the conductor is L. So here the acceleration A will be equal to minus E, that is in place of capital E, that is electric field, we can write potential gradient, right? So this is the acceleration with which each electrons will get drifted from negative to positive. So what will be the velocity acquired by the first electron when it is covering a distance of L, right? So your V1 will be equal to, you can see here, this V1 will be equal to, will be using the first equation for kinematics, that is V is equals to U plus AT. So for the first electron, this will be V1 is equal to U1 plus A tau 1. What is tau 1 actually? Tau 1 is the, you know, what is tau 1? Tau 1 is the relaxation time. Relaxation time means, you see, when the electrons are moving, there are a lot of electrons inside the conductor. So one electron, second electron, third electron. So when it is getting drifted on its way, it will be colliding with other electrons also. So the free path which is followed by an electron between two successive collisions, that is known as your mean free path. So that free path to travel, the time taken is known as your average, that is relaxation time. So for the first electron, suppose the relaxation time is tau 1. Similarly for second electron, this will be U2 plus A tau 2. Similarly for n number of electrons, this will be Un plus A tau n. Understood? Now by adding and finding out the mean velocity or the average velocity of all the electrons, we can find out the drift velocity. So you see now here, what will be the drift velocity? As per our definition, drift velocity is the average velocity of all the electrons. So this will be equal to your V1 plus V2, like that up to Vn. So mean, so they divided by n. N is the total number of electrons which are available inside the conductor. Now you see here, this will be equal to your V1. So this will be equal to U1 plus A tau 1. Similarly U2 plus A tau 2. Similarly Un plus A tau n, and n is divided, right? So now we can separate this one as U1 plus U2 up to Un right? In vector form we can write plus, now you get, if we are taking common as a, so we'll be getting, see here, this will be tau 1 plus tau 2, similarly up to tau n divided by, this will be equal to n, right? And already we have discussed that the average velocity initial, that is your 0, that is your 0. So here we will get 0 plus a, that is your tau 1 plus tau 2 up to tau n divided by n. So what is this? This is the relaxation time for each electrons. So now we have n number of electrons, so divided by n. So I can tell this is the average relaxation time. This is average relaxation time, right? So we can write this one as a tau. Tau, this is tau average. Understood? So this is the formula to find out the drift velocity, right? Now we put the value of a as we have already calculated earlier, right? So we can use this one. So we'll be finding here Vd is equal to a is minus E upon m, this will be tau average, right? Or in terms of potential difference, we can write this will be minus EV upon ml, this will be tau average, right? So this is the derivation for your drift velocity. I think it is clear to you all. So similarly, if we are finding out the drift velocity, we can find out the current also. What will be the current? Current is the rate of flow of charge. So we'll find out total charge, then we'll find out the time, then we can find out I. So in the next class, we'll be deriving the relationship between current and drift velocity. So this is a very important derivation. So I think you all can understand and you all can write. This is a very simple derivation, right? Thank you.